Hey everyone, and welcome back to the Information Bottleneck podcast. And today we have a very special guest, Atlas. He's a faculty at UT Austin and a research director of XTX, and he's living in New York City, and also he's a good friend. Hey Atlas.
Hi, Ravid. Hi, Alan. Thanks for having me. And well, by calling me a special guest, I don't know which of the point you are feeling the most special. Is that I'm a faculty of UT or research director of FTX or your good friend or live in New York City?
All of them, but mostly that you're a good friend.
Okay, then I'm honored. Thanks for calling me that way. Thank you.
Hey Ellen, how are you?
Yeah, and I'm great, and it's great to be here in New York, also in the same city as you two, so we're all shivering together in this extremely cold city, and it's really nice to get to see Atlas again, because we spoke briefly at NeurIPS, and now we get to kind of synthesize our opinions about that conference and share our minds, so happy to be here.
Yeah, it certainly feel the sharp contrast to just coming back from San Diego to New York weather-wise.
Yes.
Yeah.
So tell us, how was NeurIPS? I'm so sorry that I missed it, but tell us, did you like it? Did you enjoy?
Maybe I can get started. Well, lots of people busy, and I'm there within both hat. We, as an academic, I have papers with my student to present. And for my industry affiliation, I work with XTX, and we are a platinum sponsor of the conference. So we all have a booth. I stand there for 2 days and meeting all kinds of exciting people. So yeah, the dual hats will feel a lot of work. I didn't have even chance to see alien sightseeing in San Diego, but still I'm blown away by the warm weather and also the excitement from the people we talk to, especially on the interaction of generative AI and finance. I think that's definitely a spotlight I observed in this year's news. How do you feel, Alan?
Several things. One, I was very happy to see a lot of LLM sampling research, which is like a personal interest of my own. Especially met a few people who I even wanted to bring on as interns, because ThoughtWorks is our company's pretty openly, trying to create sampling lab, get all the sampling talent gobbled up, because we think that it works well for consulting, among other things. And so I was happy in that sense. I think I was very frustrated that they didn't use Huva, which is the conference web app. The current one that they have was extremely poorly received and did not have even close to the features. So I felt disconnected from the conference in a way that I hadn't before. And it was good. It meant that I had to constantly do in-person interaction to ask for directions or check billboards, like electronic ones, but it definitely felt like a step backwards in quality compared to NeurIPS 2024. That said, San Diego is a stunning place to hold a conference. The people there were relaxed in a way that I didn't expect for Californians, and the workshops were very nice. And yeah, the huge quantity of people. I do think it's a good thing to have more people, right? As long as we're not like totally debasing the quality of publications. And in general, I think that problems with quality are not due to just like, oh, too many people are there. So I'm happy that it's big. Though I'll just say, I do find that NeurIPS attracts way more non-researchers than the other conferences. There's lots more money for good and for bad.
Yeah, I don't think any of us would hate people coming to us, invite us to fancy dinners, right? I never hated that.
No, I like it, but it also definitely means that a lot like if you just go to a random person there, your chance of that person being a researcher with a paper is a lot lower than even at ICLR. And sometimes I do want to eat with the researchers instead of the VCs, but I realize for somebody in your position, I think the VCs are even bigger deal.
Well, first, we're only 3 minutes into this podcast. I think I already hearing Alan being sarcastic about multiple things. Which
no, I mean it. To be clear.
Okay.
I don't mean it in a bad way either. It's like,
no.
Like,
I
mean, make money.
That's a good podcast should do, right? I mean, about the meeting up, I have had a dinner with at least 2 of the past PC chairs, and we're all talking about the same thing. I mean, you are certainly not alone in complaining on that, but there are other reasons which I prefer not to discuss. And
But I think
the California's work style, okay, I'm glad you're saying that you have been thinking San Diego to be very different from California's Euro work style, which I happen to have the same stereotype as well, which is why I don't live in California. And the last thing, the VC thing. So first the disclaimer, I work with VCs and XTX, the firm itself has a VC team and I love those people, great people. And I think those days VC come to conferences and which are probably more technical prepared than some of my students, if I have to be honest. On my flight from New York to San Diego, I was sitting next to VC and he looked at me and he says, "Hey, I have read your papers before." And I thought that was a compliment. I said, "Okay, so what did I read?" And he said, "I think you write this paper, and this paper, this here." I was like, okay, my student probably don't even remember I wrote those papers. Great, I'm honored. And he said he has to read papers every day and go to archives, go to Google Scholars, because the VCs try to propel them to be more discriminative about good case and bad case, which is just challenging. Just think about how difficult we have to select good paper from bad paper. And now we're talking about selecting good money versus bad money. So I respect their work, and I love that a broader audience are reading my and our papers. So I'm probably less sarcastic on that point.
Well, and in particular, we know that a bunch of AI researchers, based on what happened with ICLR, are full on just AI generated papers with AI generated hallucinated citations.
What?
And similar lazy, and the reviewer is getting revealed and people trying to pay them off or whatever. We have a lot of terrible behavior and poor, shoddy science from our community. So I'm not surprised that analysts and others who need to make money are in some cases doing parts of or even our whole job better than we do.
Yeah, but I think it's a good question, right? It's a good question what you actually want from a conference, right? Till now, we had these research conferences that you only publish your work to other peers, that you want to exchange ideas and make better ideas and understand what other people are working on. And we have these, I don't know, business conferences that someone want to sell you something, right? And here it's kind of mixed, right? Most of the time you have you also want to sell your ideas and to exchange ideas, and you also most of the companies want treat it as recruitment event, and there are all these VCs that it's not clear even what they are doing there, right? They want to stay up to date with the latest ideas and papers, and they also want to get know other people, and it's not clear what their goal is. And I think we have this mix, and we need to understand how to do it, and what we actually want from these conferences. We as a community. Right?
That's right. I think one personal reaction I had for this is, first, I enjoy those big conferences as a one trip cost-effective way to meet all my friends. I haven't been traveling to conferences in past 1.5 years due to a new addition to my family. So this one has been a packed reunion of friends every day, and I truly appreciate this opportunity. Regarding academic intake from reading papers, let's be honest, most of us already know what's this New York's going on in paper-wise before we ever make this trip, right? Probably 6 months before the conference, we already know what will be the spotlight, will be the spot on papers, at least in our area. But I compared to the main conference post session and post sessions or others, I probably appreciate workshops even more than the main conferences, because I feel, for conference for the main conference, it's always associated with many more incentives beyond the science itself. Like Alan, you mentioned, there are people who try to press authors and reviews for bad reasons. They probably don't have the same bad reason for workshop. That makes Europe's workshop a bit more pure science, and people are also more brave in publish their half-baked, non-completed frontier ideas there. That I appreciate much more. So I actually spend a lot of time in workshops, more than I do in the main conferences. I find that is a balance I try to strike myself with, but I don't know how.
Well, I want to quickly note that the last year's NeurIPS had a pluralism and creativity workshop that Joshua Bengio and his students organized and ran. And beyond just having Joshua, who actually stayed the whole time, which packed the room just by himself, they also got Ted Chiang, the author of the book behind the movie Arrival, which was a big deal movie, and Arrival is the quintessential fantasy for all pre-chat GPT AI researchers, right, of decoding alien language for humanity. That workshop packed, like 700 or 800 people in a room. I'm pretty sure the fire department would not have been happy about that, right? How packed that room was.
Yeah.
But then even at this NeurIPS or at last year's NeurIPS, you go to other workshops that were not organized with the same kind of heavy hitters, and the room might not be packed at all. In fact, this probabilistic sampling workshop, where some of the work that we did at ThoughtWorks continue basically p-list decoding, which is like a subsequent method compared to min-p sampling, 50 people in that room maximum. So even among workshops, it's very feast or famine, at least in terms of who you can get your work in front of. And it's not even always clear when you're submitting what kind of workshop it's going to be. Like, is it going to, I mean, obviously, if you see Joshua organizing, it's going to be big. But there are other workshops that I found that get large or get a huge, and it's not clearly obvious to the people submitting that.
Yeah, but I'm not sure why the workshop turnout or the population size is a good indicator of the return you can get from the workshop, right? Like you said, the stochastic sampling workshop or other more mathematical principle foundations workshop. Sure, you will never get a big packed room, but you get good audiences. This is always a signal to noise ratio, right?
Yeah.
I'm also co-organizing a workshop this year on generative AI for finance, and that's a very packed room as well. But I myself also emerged in a few other workshops. One is OPTML, optimization for machine learning. I'm always in this workshop since its beginning. And I think I have talked more and learned more to this workshop than many others. We all have our sub communities, and if I'm in a room of only 15 people, but those are 15 people who can 100% comprehend my work, this is the best workshop I want to be.
Yeah, I agree. Well, talking about like conference dynamics is an interesting thing, but I think you have a lot of, I mean, you're quite yourself, and most of the students you work with are prolific and productive, and you have a lot of research that we'd love to start asking you questions about.
So you want to be revealed too? Get started.
Yeah. So I mean, I guess the first question is just like, what's, your favorite thing that you've worked on, or even your students, if something your students have done is more exciting to you, I guess, maybe this year since it's nearly over.
First, I like the way you raise the question that try to differentiate my students' research, and I think this is very fair. That's a question I like to ask my students. Some of them are not faculty members as well. For myself, I always like one research theme called low dimensionality. I did my PhD in the background of signal processing and optimization, and my first research topic was called compressive sensing. I don't know how many younger audience are still aware of this direction, but that's still very deep, close to my heart. Sparse optimization, and then it went to low rank and nonlinear manifold, and I just keep enjoying doing that until after a few years, I realized I cannot publish a single paper because everybody enter a new area called the deep neural network. So let's get to that new area too. But to my profound joy, after I went to exploring those over parameterized neural network, I find that there are more opportunities for me to practice and actually deepen my understanding of low dimensionality. Prominent examples may include pruning, lottery ticket hypothesis, low rank, and mixture of expert. And I have had great joys studying all those things and by practicing what I have learned in sparsity, low rank, and low dimensional manifold. And this has been the line of work that I continue to engage in my own interest and effort. In the recent years, my student and I worked together on a few efficient inference and training algorithm, large foundation models. Some of them, I think, are reasonably welcomed by the open source community. But if I have to name one favorite work I myself did in the past 1 year, that's probably a pure theory paper that I haven't found much of the practical usage yet, but I like it anyway. The paper is called the paper analyzes how neural network could probably learn symbolic equations by gradient descent. So there are many recent deep learning theory papers that study how gradient dynamics are going to drive neural network towards solutions of structured properties like sparsity, low rank, low entropy. Those are pretty known to the community. However, how to close the gap between continuous dynamics and discrete structural learning is highly non-obvious because we're always using tools from the continuous
Let's
side.
Atlas.
Yes.
Wait, let's go a step back. What does it mean actually, like symbolic neural network? Or like how you actually look, why we need to care about it?
Well, you want logic and rules, right? Logic, rules, and association relationships. Those are things that you could write with symbols. And I want to know why neural network is not just learning a huge bunch of black box functions. Instead, it's something that could be mapped to a low-dimensional symbol space. The reason I like that is because I consider this to be, I would say that without proof, the ultimate form of low dimensionality. We use deep neural network to learn big functions, and then discover that those big functions can nail down to some much lower dimensional things. Lottery tickets is one prominent example, and we have a lot of sparse, low rank, and other low dimensional stuff we can apply to deep neural networks. But for a pruning algorithm, you can probably compress by 50%. For a low-rank algorithm, if you are doing fine-tuning, of course, you can compress by maybe hundreds of times compared to using a full matrix. But I would argue that the biggest compression of neural network is to compress a neural network into a non-neural network. That means compress what you have learned into knowledge that you can write with symbols, like what you have read on textbook. I would argue that a human textbook, human knowledge that can be written and recited like we're doing now, are the best form of compression, and that will not be a neural network. So that's the goal I set for myself. I don't want to compress neural network into another neural network. Distillation, low rank, sparsity, that told me a lot of things, but now I want to compress them into a discrete form, a symbolic form, and eventually maybe even human readable language again.
So when you start talking about association symbols, I think association rule mining, right? And I actually started my career in machine learning, at least with like my college classes, on learning all the ins and outs of a priori algorithm and alternatives to it for better association rule mining. And I was always fascinated with that algorithm, in particular how it relates to databases. It felt like automatic database construction. Yeah, and that I feel like it's not
We're
explored
still
well
using
enough.
associative memory, right? Every day in
Yeah.
Transformers.
Yeah, and beyond that, there's all these apocryphal stories about like people where Target or whatever discovered that somebody was pregnant before they did, and was like sending out, ads for diapers or whatever using association rule mining techniques. I also hear you talking about dimension or at least low dimensionality. And I think dimensionality reduction, right? You mentioned like manifold methods. I am a strong believer in the importance of unsupervised learning and think that it's been unfairly devalued by neural nets, both dimensionality reduction and clustering on low dimensional representations. And I point out that models that perform basically the task that unsupervised is often trying to do, at least in image space, the SAM model, right? Segment anything model, is a great example where the ideal, I think, image clustering algorithm does the same thing of segmenting your images in a logical way. And when I think about how humans learn, I claim at least like the majority of like a baby's early experiences are unsupervised, right? They have unlabeled data that they learn the relations to by just figuring out what objects are, like this apple is not the glass on my table. Like that's all you need to be able to learn a lot of things without labels.
Because this is a life experience, and now I have every day with my 1 year old. Well, I have to point to that apple and keep telling my son, this is apple, apple, and apple. I don't know how effective he's learning, but I'm trying to give him some supervision. Okay, going back.
But your labels are very sparse compared to the data that they get in an information theoretic sense.
But it's not. Yes, again, I also a big believer in self-supervised and unsupervised and dimensional reduction and all these. But like we need to to make sure that we are not making this connection, we are not taking it too far away, because you don't know the prior knowledge here, right? Like you don't know what is the prior knowledge that humans has, right? Like you don't know how much, like, again, prior information encoded in the brain, that you only need like some small amount of information,
But we have
or labels
echoes.
or whatever.
Yeah.
We have Morvick's paradox. We know that we've evolved to be able to do things like walk and run over millions of years, which is probably why it's so hard. One of the reasons why it's hard for AI. So we have echoes of evidence of what's prior and what isn't. Like
Well,
mobility is probably prior.
We all know that every theory is wrong, just some are useful, right? I think the same can be applied to mathematical priors. I was just talking about my journey of low dimensionality priors, sparsity, low rank, manifold, and now symbolic. I mean, all are trying to describe this thing from different mathematical perspectives, but I don't think any of those is buried in our brain, right? Of course, there are biological sparsity, but really, I don't think when I was learning things, there is a L0 norm in my mind.
Yeah.
Yeah,
that
but
makes
things
sense.
I think
things
it's
are decided by data. I agree with you. Sorry, Rabbit.
no. Again, I think that, like, in principle that's true, but it's not clear to me. Like, there are the optimal solution that, like, we may want, and there is the practical solution that involve the optimization process and the representation, and how we define the thing, and how, like, what the kind of data, specific types of data, and all these things. And I think we need to be careful to say, oh yeah, like humans are like that, so let's try to push to this direction. But
Right.
again, I think this is a good paradigm, like dimension reduction and compression and unsupervised and self-supervised learning is the way to go. But I don't think it's because humans are doing that.
Well, I remember Yang has a famous saying probably more than 10 or 20 years ago, right? Like human build airplane, but it does not swing like birds. Yeah, probably many years ago.
Yeah.
Yeah, I agree, but
Okay.
I I do think as long as the information theory still holds true, low dimensionality pursuit will be there, and that's why I like your work a lot too. Yeah, Rabbit.
Thanks. No, I'm a big fan of compression, right? Like a lot of my work is about compression. Okay, don't get me wrong. Okay, so we understand like why we want why to learn symbolic concepts and models. Tell us what you want to do with that.
What you want to do practically, or what you don't want to do proof-wise?
No, both. Let's start with practically.
Then you are effectively muting me because I don't have a practical application of that theory yet. Okay, I'm kidding. Let me
So
actually
let's do it in theory.
Okay, so let me answer. Okay, let me still answer this from practical to theory way. So practice, like I said, I was initially driven by the desire to convert neural network to symbolic, and two most obvious benefits are number one, efficiency, because running a, let's say, light GBM tree is in any way much easier than running any neural network, however you compress it or distill that, right? In general sense, of course, I'm not talking about specialized hardware. And in some extremely resource constrained or latency sensitive applications, for example, CPU based, like in networking or congestion control, those basic CPU tasks, the symbolic equations are much better controllers compared to neural networks or reinforcement learning in terms of resource. So one of our early work was in collaboration with ML6 folks trying to first learn a reinforcement learning to control the networking congestion in CPU environment, and then convert that reinforcement learning into a decision tree. And if you care about the speed, that's immediately 400 to 500 times the acceleration on CPU environment. That's pretty straightforward. The conversion is done by Gaussian fitting, the basic way in symbolic regression. But we see that works, and that's and in that specific case, way better than any network compression algorithm we have tried. It's not 10 times, 20 times, it's hundreds of times. And then we pivot a bit to interpretability. We trained a visual reinforcement learning algorithm on OpenAI Gym environment, let it play in the simple visual games, and then try to convert that CNN-based reinforcement learner into, again, a symbolic tree-based parser. So we see how this learned symbolic algorithm started by grounding color patches into object in an unsupervised way, actually, I would say. in the and then use learned associations and logic operators to combine those base units and make decisions. It's also a decision tree like thing, and started from some like object partition. You can consider it automatically learns how to patch and segment the input image patches into semantically reasonable subject, and that's maybe what we want to do in the mid-level vision anyway. And then the decision-making algorithm operate on terms of the small patches. And we have a paper on PAMI on that. Although I wouldn't say this, I have to be fair, I don't think this would scale up very well in complicated vision control-based lab. We are just playing this in like open Minecraft type of simple visual images. But I think that again shows the possibility the neural network are actually just learning composable logic plus perception, which plus the perception modular, which can also be discrete. And one way to do it now appear to be the SAM model, like Alan just mentioned. We can convert continuous things into discrete things, like we're doing with grounding in robotics. So we have a few more work along this line on different applications. I think efficiency and iterability has been two main driving forces. So, and we are not alone in doing this. We have seen great work from Flatiron. Shelley Hall's group has been doing a lot on that, and Michael's group in Cambridge has been doing symbolical regression. We like their work a lot too. Seeing all those empirical work, I have been holding this question from 3 years ago. We have been discussing with my student quite extensively why this is possible. I mean, neural network is a universal approximator. If you try to be lazy, you can use this to answer anything in deep neural network. But the true question is, why neural network would care to learn alien symbolic formations, for example, a reduced order polynomial? Why it has to be this way? I always want to use a simple example, not fully precise, but a simple example I used to ask myself when I was a high schooler. Why Newton's second law is 1 over r square? It's not 1 over r square 2.015 something. Why this is a beautifully simple r square? And if physics PhD could have done integration to show the r square must be there, but if Newton was using neural network to fitting this, actually I'm talking about Kepler's work, but if Newton were to use today's neural network to fit this equation, the neural network probably will not tell Newton this is 1 over r square 2, right? It will be some weird equation because the neural network does not build with the sense of learning clean, compact equations. And even this notion alone is very hard to describe. How you should tell your neural network to fit a function that is a clean size function. What does it even mean? I think there's a lot of human prior here. So I was trying to so my student and I are trying to start from analyzing simple theoretical cases. Learning a polynomial from synthetic data. And we're trying to learn problems whose underlying structures include compositional, algebraic, and logical relationship between input and operand, beyond just doing statistical recognition. And we have done some simple theory assuming some basic mathematical group operations and ring structures, and prove some theorems to show that actually, if your data generation process follow algebraic structure, then we can prove neural network indeed is able to discover that underlying symbolic structure precisely by using gradient descent, which was amazing to me because gradient descent is a continuous dynamics, and you're trying to reach a discrete target, and we show that they can converge. And that is done by some mathematical tools. For example, measure space analysis Watson-Stan gradient flow of functionals. I would be happy to throw you the link, but probably let's do not spend the whole time on the proof here. And sorry for getting me a bit more excited about that. Sorry about that.
No, that's great. But we have this, you proved, right? And you also showed something that data that you can have discrete problem, and with gradient descent that is you can actually converge to the real solution, right? To the optimal solution of this.
Yes, we show they can find a solution, but the caveat I mean, beyond all other things you would expect from a first, I think a first of its kind proof is very preliminary with a lot of assumptions. I have to confess on that. A major caveat here is our theory does not provide a construction. It's existence proof. So I'm not saying that I can get rid of the neural network and directly reach that symbolic equation. I like the situation in lottery tickets hypothesis. I know there's lottery tickets that exist somewhere in initialization, but there's no good way for me to pick it up. So I think there are way more work to do for us to both push this theorem into a really practically verifiable case and to directly reach the symbolic equation without going through over-parameterized training. I think later would be a holy grail problem I want to look into next.
Okay, so and I want to ask you, like, okay, what next? Do you think like this is something that is generalizable to other problems? Do you think like this is something that, okay, this is the way to go? This is the way to go, like to try to formalize concrete problems in very rigorous way and to show that like HD can converge to these problems? Or like do you think this is something that like we need to go to other way, right? Like to try to make relax these assumptions, and maybe we will not show it like rigorously in a mathematical way, but it's still fine and like we have some approximations.
I think I think I actually already answered that in how I approach this symbolic problem. Basically, do those things in parallel. We do those empirical proof of concept, and we do the theory in parallel. One does not necessarily wait for the other. I like doing rigorous theory, but I really haven't seen like any. I mean, let's put it nicely. I mean, it's very rare that a rigorous theory will drive an empirical advance those days. So I prefer do them in.
So what kind of problems do you think you actually show it? Or like what type of problems, even like if you don't, if like you're not, if you can't show it like rigorously, like what kind of problems neural networks are good in solving?
I think what I'm trying to look at this symbolic thing belong to the broader problem class of building mathematical foundations for reasoning. Reasoning itself have a lot of logic and discrete structures involved. System 1 versus system 2. And how neural network get to learn those things, I mean, even with the chain of thought involved is basically a miracle. So I have been working with some colleagues how those COT-based things could be represented in as, a superposition of logics, and maybe our theory can get somewhere from there, and that's something we are still on the work. But we also want to work on practical side of reasoning, and I'm not saying that we have to necessarily wait for theory to complete. I would say they just fulfill both sides of my curiosity.
And do you
So-
think actually, do you want? Yes.
No. Keep going, Ravi. It's okay.
So, okay, so I'll try to push even further. Do you think reasoning is actually like useful, or something that it's some kind of like, I don't know, local minima that we have now, and we can bypass it with more advanced models? Like, why we actually need reasoning?
Well, let's first define reasoning, which you call as reasoning.
Right, yeah.
COT, reinforcement
Right.
learning?
Yeah.
What specific kind of reasoning? What do you mean by reasoning?
So yeah, I thought it more like, yeah, let's say RL reasoning, what people call reasoning model, more chain of thought, like all these groups of solutions. Do you think it's actually helpful? Not helpful, but like for the long term, do you think we these are essential for better models, or we can make better models without it?
Well, I'm not sure about it. I don't know any algorithm is truly that necessary if you have good enough data. I think, well, we all know that frontier labs are very heavy on data. I think all the algorithm can be viewed as some sort of search in a high dimensional data space. If you have designed a good architecture or good optimization algorithm, you start from a good inductive bias of search. So that's that warm-up initialization that usually serve you well. But if you have really good sampling of data from your target distribution and keep running random sampling even, maybe, that will perhaps also bring you where you want to go. I mean, I don't have any theory on that. I just, because in my current industry role, I work for XTX market. My work involves a lot of large model training as well. I feel this is also a process of moving my belief away from highly crafted or specialized algorithm or model design to more fundamental problem setting or data distribution, more and more inclined towards scrutinizing the later that usually give us more performance boosts. That's probably what I can say.
I wanted to join in on this because I remember a paper, I think it was from more than a year ago. It might have been like an ACL paper from late 2023 on this overarching question of getting symbolic representations from, techniques with gradient descent. It's a ridiculously simple technique too. They were talking about,
Wait. This is my paper? Probably
not your paper. No.
Yeah.
I'm talking about a paper related to this that I saw. No, this paper, I don't remember the title, but the idea was for any neural net, you can get very accurate, fully explainable, extremely cheap spam classifiers, right? And all they do is they prompt the model to generate like their own anti-spam classifier. And so it will like generate keywords or some other pretty good heuristic that's super explainable and ultimately creates a set of if-elses that make it basically a decision tree. And then you can use that for, figuring out if something's spam or not in the real world. And they show in experiments that the models that are created are pretty good, right? So I'm intrigued by this idea of just asking models for symbolic representations. And I'm wondering, obviously this is nowhere near as elegant as I think most of the stuff you're directly talking about, right? But I'm just curious what your thought is to this approach.
Well, I think this is an interesting approach. Although I think your belief in this approach is basically your belief into how well the model alignment is doing right, in that specific dimension, and language and if language model will be talking regardless of what you ask. So so the data quality you get from language model really depend on the quality of the question you make for them. And I think that's why many LM papers are such hard to reproduce. But okay, going back, I think you are asking language model itself is definitely a very interesting research direction. And in a broader sense, I also call it neuro-symbolic AI because it is generating symbolic language, and the language itself are subject to symbolic checkers depending on what domain you are. So sure, this is a very interesting interface that my research group is also personally looking at. We have done work to show you done work like asking language model to propose planning solutions and then send the planning solutions towards the security checkers if that's a domain subject to compliance, and use that feedback to run DPO type of thing to directly optimize the language model to make it more compliant. Then if the data is good, the question you asked is good, and the base model is good, you will be able to get this positive data flywheel going on. And you can. No guarantee to my best knowledge, but yeah, you can get that work.
I have a question. So what do you think about how it's connected to all the JEPA style learning? Like you have some internal state that you want basically to separate between the generation process from the learning process. And in some sense, like it's not discrete, but like you need some state, like internal state that evolve over time. You can think of it a bit as like symbolic model, right?
Well, is it the necessary question for anyone coming to your podcast?
Yeah. This is our. We need to change our name to JEPA.
Okay.
The JEPA podcast, but I think yeah.
I personally read the JEPA papers. I at least went to. I think I went to 3 or 4 Yan's talks on JEPA to make sure I understand all those concepts. It's a beautiful algorithm. I like the MPC concept, model-based predictive control, and I think Yan's idea on combining this with JEPA representation is beautiful. I also think it's deeply connected with other things that we have known better or earlier in deep networks, in deep network dynamics, such as the Koopman operator, which I'm also very interested in. I, however, do not think anything is all functional fix to all the problems we have in deep learning, because every learning algorithm has to assume something, and that's a sacrifice you make to the real data. Again, this is the second time I mentioned I said about this quote. Every algorithm is wrong, some are useful. I definitely belong to JEPA useful algorithm.
Do you think that it's going to remain the core architecture behind world models?
Well, I don't personally claim to be any world model expert, so I don't know if I'm a great person to answer this question. I just feel like I just feel like I have said, once the data have come to a point, all algorithm will converge. I'm probably a believer of the great convergence theory in model and architecture. I think there are all different avenues we take to achieve the final truth, which is data dependent. Or maybe that is the joint entropy of data distribution. Who knows, right?
Yeah, do you think everything is just the data? And then do you think like we will converge with good enough data, we'll converge to the same type of solution, whatever algorithm we will use?
Well, yes and no. I think this is like the argument we have between neural network expressiveness and the practical usefulness. Right? If neural network is universal approximate, we know that from the early 90s. But if we already know that by then, what we're doing in the past 30 years, we develop a new neural network architecture, ResNet or faster RCNN that just receive a test of 10 word. That's because although neural network can, in theory, learn everything, it does not have to happen in your experiment. Your experiment is further decided. Your experiment quality is further decided by how stable your optimization could go, how well your hyperparameter chosen, how good your architecture scales with your ML system, how does your architecture favors DDP or FSDT or other things. And I think those lottery design choices has been mattering in an unproportional portion in affecting the deep learning progress. So every algorithm are more or less useful. That is my view. But some algorithms are more advantaged in today's ecosystem, and we should honor that. So when I'm doing research, especially now, I'm doing part of the part of my industry research. I'm less religious about the algorithm is right or wrong, but I do think there are more suitable for now and less suitable for now algorithm give what we have. I hope that is more or less answering your question.
Yeah, I agree. I think I agree. I think it's a good point. I just feel that it's really in real time it really matters, right? Like all the small tweaks and all the small algorithms that what we are going to do and how we are going to do it. But after you achieve it, then it looks at now you can come up
do that
with
in many other
so
ways.
many. Yes, and it's quite surprising, right?
Yeah,
That when you achieve
very close to my heart. Yeah, once you know how to do it, once you know the first way to do it, you will know the second, third, many other ways to do that immediately. Yes, that's indeed what I have said.
Yeah, what do you think? So one more question that's related to this. What do you think about synthetic data? I just saw, I think it was Alex Diamkis. I think he's in Berkeley now, professor at Berkeley, that said that they are doing a lot of synthetic data sets generation, and they are working on different directions. But one of the things that they found out is that if now you need to create a data set, let's say that you need to create a data set with 1,000 questions, okay, and you're using some LLM to label these questions. I don't know, DeepSeek R1 or something like that. Apparently, if you have, so let's assume that you have one data set that with 1,000 questions and one answer for each question, okay? And if you compare it to a data set with 500 questions and two answers for each question, then it looks that the 500 questions data set is better, or gives you better performance when you train on this data set. It contains more information in some sense. And think about it, I know it's quite weird, right? Because you have in the first data set, you have more questions, right? And this mix between what information we have in the questions versus what information we have in the answers and how they interact with each other is something that I don't know a lot of work about it. So yeah, what do you think in general about a synthetic data set and how you actually use it in real life?
Okay, yeah, I can have two part of answer to this regarding the regarding comparison between you want to have more questions or you want to have less questions but more answers. It's actually the first time I heard the example you said. I would look into more, but I think earlier, a few months earlier, my friend Professor Alex Demarkis of Berkeley, he was rising. I think he was posting about that paper, his paper. I'm not sure, but he definitely has posted that paper saying that you can just train reinforcement learning using one question, just using one question, getting to the answer, and then pushing the model again. Could you do it a bit more differently? Could you do it more creatively? Could you do it with another way? And keep doing that and see the model, a lot of self-improvement on some small base model as well. And there may be another paper related to this idea. I think I have seen two. And that's quite interesting. And when I look at reinforcement learning papers, I would like to connect back to our own life experience. I remember when I was a high schooler, I was practicing my math. I first look at, I do a lot of math exam questions and try to make myself just practice myself. And then my teacher look at me and saying that, no, I don't want you to do this because that's a great waste of your time. I want you to work on this selected book and then keep doing this question once and do it again and see if you can solve it better and eventually better than the standard answer provided to you for reference. And that become what I followed. That didn't make me a good mathematician, but I think I have seen both sides of this practice. Sometimes a deeper tool is better than the diversity of the problem you look at. I can see why this makes sense. It's just trying to, I think it is at least, I try to understand it as squeezing the salt value from the thought process. If you just look at the question, get an answer, and give it up, it's like you are being served a dish and you just give one test of it. You didn't really finish it. There are more intellectual value you can get from this question, and that's how you can benefit from repeatedly chewing this question, testing this dish. So while I haven't looked deep into the paper, I think I can buy this idea, and I think this that's an inspiring one. Second, to the synthetic data question. Yeah, I can comment from my practice. I think synthetic data is actually a luxury you only have in certain domains, right? Probably language and vision, and maybe speech, but I don't personally work on speech. Those domains have a commodity. We have all worked in these domains for years to make first discriminative models work good in the domains. Everything starts almost from a recognition type of thing, right? Classification, recognition, and then we do other types of more difficult discriminative question, maybe labeling, maybe detection or segmentation whatsoever. We have and we made sufficient progress on discriminating models and built a large data sets for them. For example, ImageNet was not built for generation in the beginning, right? And even Lion was built for captioning, not for today's generation in the very first stage. Actually, and only when the discriminating models has worked well enough, we went to the generative model stage, and we reuse the high-quality dataset we built in the discrete stage. And it is also so natural from the machine learning common sense perspective, because the joint distribution is always the hardest to learn, right? It's the god of all distribution. And so that's a natural process. Only when you have the good generative model and learns the good joint distribution, we can start talking about the luxury of synthetic data. So this is such a high bar that only a few lucky domains, including language and vision, have. And I personally now working on one of the very unlucky domains called high frequency trading. Well, if anyone knows how to build generative model to generate the everyday stock market that I'm looking at, please, if you are listening to the podcast now, I would like to talk to you.
So
Or you
real
can,
quick,
make your own hedge fund and.
I'm sure that taken off.
How important are things, and mind you, I'm asking about like the industry in general, right? Like how
Please.
important is cabling to high frequency trading, like for example being close to those data exchange hubs where data like comes in on those undersea cables. I've heard that things like that and like ASICs and FPGAs are very important because for high frequency trading, my understanding is that you have like in some cases nanoseconds of time to make decisions based on information.
Yeah, speed is very important, but there's also no denying that generative AI revolutionizing this industry. That's partially why you are seeing such an enthusiasm in both the exhibition hall and the workshop rooms in Europe last week. Ravi, you were asking what I can say about this industry in general, or usage of AI.
Yeah, like what types of problems that you think are interesting in this industry in general?
We don't have a lot of problem types, although each problem is have to be very deeply studied. The most popular, I mean, the most useful, the most common and useful, and perhaps the closest entry-level quantum research question is time series forecasting, multivariate time series forecasting. You take input features from the market exchange in high frequency case. You take input feature from market exchange that including price, volume, and transaction record, blah, 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 other metadata for each stock. And you may want to look at mailing stocks together to build the so-called foundation model. But the goal is for each of the stock, you want to predict their price or at least the direction after a certain period. And that certain period called horizon usually decided by what execution strategy you use. So it's a very classically defined question. And the problem is a classical Y equal Fx. Y is the future price, X is the current price and past price and other associated information. The research challenge here though is the data is extremely noisy. And as I said, I don't know how to best utilize the blessing of synthetic data because we feel if you work in the high frequency field, you are we are not short of data. The exchange are sending us data every tick. The issue is we are short of high quality data. And there is no obvious way for me to tell whether today's stock market is better than yesterday. And note that here by quality, I'm not saying the data itself has mechanical error, transmission error. It's not. And we have great data team to help us ensure the data quality are as authentic as possible. The issue is the market itself is always dominated by noise. So that makes this time series task specifically a bit like predicting noise from noise. And in fact, if you work in this field, you know the prediction result is very much like zero correlation. And that's why typical quant, it's actually challenging for typical retailer investors to beat the market itself. For example, S&P is a very good risk neutral baseline, and it's very hard to beat, and people all know that, right? We did so many efforts just to make our prediction accuracy to be a little above zero. And that a little margin is very small for all high frequency quant. But because this industry, people trade a lot every day and every year. The total trade we execute is an astronomical number. And with a small margin every trade, but do that a lot of times, then the law of large numbers will be your friend and materialize this probability into a number that are enough to cut into your checks. That's what we do.
But do you think it's such a hard problem because at the end you don't have one solution, right? Like it's not like it's not deterministic, right? Like you don't have like I don't know, you don't know at the end. Like it depends on the opinion of so many people, right? So it's really like even if you have all the information, let's assume that we have all the information. Even in this case, it doesn't clear that you actually can like guess a good prediction, right?
Of course, yeah. Yes, by definition, market is a multi-party game problem, and the number of participants is so large that it's impossible to have any analytical solution. In the specific case of high frequency trading, I would say this has been less considered as a concern because the time you have to make a trading decision is just such a short horizon that let's put it this way: this is too short for anyone to plot against you, if I can say this way. It's not necessarily true in recent years because there are more advanced things people are doing anyway, but I prefer not talking about that. So yes, the multi-party game concern you have was not a major concern, but now it's getting into real as well. for some reason.
And without going to a specific details about models, I think like at least from someone that looks on it from outside, it looks at like, there is kind of like a lot of companies are actually trying to build and like to become less conservative, right? Like many years these companies were really conservative about the models, and actually like the models themselves like were really simple in the sense that like they didn't follow after the recent advantages in machine learning, right? And it looks again from the like really looking it from outside, it looks that a lot of companies are trying to take some methods and take some a new frontier ideas from machine learning to make better prediction. Do you think this is something that like you see also in the field, or you think this is something that will become more and more? Or do you think some like you will see that we will go back to more classical methods?
Well, I think the benefit of generative AI for trading is real, and because there are at least a few companies, including XTX, has delivered the benefit, and I think people would believe in what they see. For the trend, it's also real. I think Alan and I both see what's going on in Europe's conference. And finance and the entire finance industry is of course very excited about AI tools because anything that can help make profit is good. Different sides of finance industry may have a different take. For example, some might be interested in leveraging LLMs to automate their workflow. Some may want to use a foundation model to read the internet or dig into social network and find what we call alternative alphas to, like, for example, sentiment about the company. This is a famous example. And some like us and a few other competitors are trying to build a better foundation model ourselves, but not about language. It's about the time series, multivariant time series, and the big collection of them received from the exchange. So instead of a symbolic language foundation model, like everybody else talking about, we're talking about a numerical continuous stream time series foundation model on time series and a few other things. So people have a different target and a different usage when they talk about AI. But one thing that I think we can make no mistake on is that everybody, yes, is trying to use AI. And I can also see AI is already delivering in many of those firms. It's probably no stranger news, no stranger news anymore that there are banks and there are trading firms who already either built the AI center or aggressively post the job post about we are hiring more AI researchers. So I'm also telling my students that if they're interested in finance, this is actually a very good year to jump into finance job market or to at least feel how it's like. Yes, all my students are interviewing as well. Regarding whether all of them will deliver, that I cannot predict. But I guess even we look into the tech market, we even cannot be sure which of those AI, whether all of the LM company will deliver, right?
Yeah.
Finance are slower in catching the trend in general. The dynamics of finance is always lagged, and then EMS smooths the trend compared to what's going on in the tech field. I think some people will succeed. We already seen successful examples. That's the most important thing. You cannot convince finance people with papers. You have to convince them with annual returns, and that already happened. People will move into the direction, and I expect to see more companies to keep investing, and some of them will succeed.
And do you think so? So classically, like let's say the average profile of that went to finance was, I don't know, a graduate PhD math student, right? Do you think we will see more and more ML people that actually build models, AI models that know how to deal with models, or we'll see some mix? What do you think will be the future direction in the profiles?
Yeah, that's a great question. Because I'm also hiring. I can share one of the mottos that we hire quantum researchers here, and that was not my credit; it's a team credit. We want mathematicians who can write code, or engineers who know how to speak math. Maybe they mean the same thing, but I think compared to I think in general, the hiring preference of frontier financial AI companies, if I would coin this terminology, are become more and more aligned with the frontier AI labs people are talking about. It's pretty common for me to see people in our candidate pool to have compete offers from OpenAI, Gemini. It actually happens from day to day. If I want to name one relatively unique preference to finance, it's perhaps we still hold our preference towards mathematic and statistical foundations. Like,
But
okay, you will still not get away from the problem like tossing 1,000 coins was the first time you see HHC. I promise you will still see this question somewhere, not necessarily with us. But we want people who still can, how to say it, because our data is very noisy and you still need to do your research work to even you go with a foundation model recipe. There are still a lot of research you have to do to bridge between the foundation model built for clean, structured language to the noisy, less structured time series. And there are many mathematical transformations linking this bridge. So this is just one example. So we still want people who have those common sense. Among my colleagues, there are top mathematicians, top physics researchers, quantum researchers, and of course, computer scientists and electrical engineers. Eventually, nobody come out with a PhD degree in trading, right? They are just mathematicians who can write code trained by different disciplines.
yeah, I agree. I'm not sure, right? Like there is all this debate recently, like what will be now when you have all the AI tools, right, that know how to write code. There is this debate, what is the best, degree to actually learn and what you actually need to learn in these courses. In do we need to, I don't know, to know how to transform a matrix or not, linear algebra and all these things? So personally, I believe that, yes, I believe that like in the last 30 years, the best choice was to actually learn something like as mathy as you can, right? Like to learn linear algebra, to learn like calculus, to learn whatever you can, as much as you can. It will be better in the job market, right? But it's not clear if this will be the case in the future, even for AI research, like let's say pure AI ML research.
Well, that's why you gotta get your plumbing license as soon as possible.
Well, that also depends on how soon you believe embedded intelligence is going to succeed, right? Not even 100% safe.
Well, I
Yeah.
still think physically demanding blue collar work like that will survive a bit longer than or other types of physically demanding work. Like for example, it's apparently easier to create loitering like munitions and replace soldiers than it is to do plumbing work because we have a lot of the munition stuff already.
Yeah, and maybe I agree, and maybe we can also look further into areas where the either data availability is is less sufficient. Areas where proprietary data war has been held there, and there is no much way to penetrate that. I think finance also belong to the last area. They have this is very hard for a generic public model to penetrate the private knowledge war. And the private knowledge accumulated in finance industries in the last decades is definitely valuable. And you cannot easily override that with public knowledge. That's my personal opinion.
So what do you think about all these competitions that let, I don't know, Gemini, ChatGPT, DeepSeek, like they give them a free trading account and let them trade over 2 months?
That's an interesting experiment. I will not put my personal money in it.
Okay. No, that's I agree. Anyway, do we have anything? Do you have anything else that you want to talk about or like to comment about?
Well, not really. I think we have touched many interesting point. Actually, more intense than I thought. Still better than the review 2 I get, which I appreciate. The last word I want to comment is maybe I can add a last word comment because and to just better fit the industry hat. I'm worried. I personally think. I mean, when I did my PhD 10 years ago, I didn't actually give much of consideration to the financial industry because I was under the same stereotype of perhaps many people have. This is a linear regression, lasso, and the decision tree. Paid very well, but I want to do by that time, computer vision or the machine learning stuff. But now I can see this field is embracing a real change because of the pressure of real market success, but heap. And those two are very different, right? You can enter a field where you hit a lot of heap, but then you find it's very difficult to find one company that actually making money and rolling the flywheel up. But finance had already proved the concept. That means it's already past its infanthood and it enters the maturity time of using AI. I firmly believe this we will see the explosion of AI in finance because someone proved it will make money. The research problem here is amazingly rich and amazingly difficult, and I'm saying that in a positive tone. I was personally facing choices between going to for example LM group and the current firm I'm working for, and I was debated a bit, and then I made my current choice because I feel if I join LM Foundation Lab, I think I'm a reasonably smart guy. I can learn how to do pre-training or post-training if someone guides me. But joining my current firm will allow me few dozens of people to know how to do right in this world. And because of the unique data access, the ample GPU power, and the talent density you work with. And I think I like I always like being unique in my research journey. And I think in that sense, I'm very happy with my current firm. So the entire industry will open more opportunities, and I believe some of them will succeed. For AI researchers, especially new grad, when you look at the job opportunities, I would offer the advice, please look at this industry more seriously because we need people to do research. I think we pay people pretty reasonably or unreasonably well. Maybe compared to today's tech industry, we have better work-life balance. That's all the word I want to say.
Yeah, great summaries. I think like we should talk about actually like work-life balance once day because it looks there is a huge like some companies really emphasize and really know how to do this work-life balance, and some of them it's terrible, and people think that if you will work much harder and if people will work 20 hours a day, they will get better results.
Yeah. I have a small sample size of my graduated PhD student. Some are living a happy life. Some basically disappeared from social life, so I can observe.
Yes, yes. And in the bottom line, it doesn't, most of the time, it doesn't matter, like for the final product or like for the final result. So
Yeah, but this is but it's
why to
today.
do it?
Yeah, but it's today's culture, and it's great for young guys and students to be motivated. So I wish them all the best. I wish them the vesting schedule all work well for them.
Yeah, and without specify specific names, right? Um, anyway, Atlas, thank you so much.
Thank you.
Yeah, it was
Ellen,
a
do you want
pleasure
to
to have
say
you
something?
on this.
All
Yeah.
right, thank you. This is a great conversation. I actually feel more energized after talking to you guys, and I will probably through the paper anyway because I really like that paper.
Yeah, yeah. Thank you so much, everyone,
All
and
right,
see you next time.
see you, and thanks everyone. Bye.
Bye.